Welcome to day 4 of my AVR Advent Calendar. In this series of videos I show you in 24 days how to program the AVR 8-bit microcontroller. And today I don't have a bag because if I would have one the bag would be empty. Today we'll talk a little bit about some theory we need to know when programming microcontrollers. So the topic for today's videos are bitewise operations and how to use them to program a microcontroller. But let me make it a little bit more specific. Here you can see I have printed out one register. So this is the port B data register. And in this register, if the pin is configured to an output, if we would write a 1 to 1 byte here, so pin B or port B pin 0 would output a high level. And if we write a 0 to each bit, it would output a low level. So, but how can we program it? Well, if we are using C, we can use the name here as a macro, so it's already predefined. And for example, if we want to set pin 0 and pin 1, what we would have to do is we would have to use the macro port B is equal to 1 shifted by 1. This will set this bit here. Or 1 shifted by 0, so this will set this bit here. Okay, and what the compiler will do then is it will see this macro and it will substitute this macro into the address of this register in the address space of the microcontroller. The cool thing about using these macros is if we want to port our application to another microcontroller with a different memory mapping, the compiler would automatically change this macro into the right address. So this is very convenient. Okay, but now let's talk a little bit about some bitwise operations we will need to set bits here in this register. So what we already used was the shift operation. So the shift operation is, for example, left shift by 1. And what this do is it will take this 1 here and shift it 1 bit to the left. So the value gets, instead of a 1, we will get a 1, 0, so a 2 here. And we've already seen the OR operation. So this was this here. So I had 1 shifted by 1 or 1 shifted by 0. And this will give us a 3 here. So this will set this bit here, and this will set this bit here. And some other operations we will need later are the the AND operation. So for example, if we want to AND 2 bytes, or 2 bits, bit 1 and bit 2, what we will do is, or let's say 2 bytes, let's say B1 is this here and B2 is this here, and if we would AND these two values here, we look at this, and if both are not 1, the result will be a 0. So here we'll get a 0, here we will get a 1, 0, 0, because here only 1 bit is set to 1. So this is the OR operation, and the last important operation for us is the invert operation. So invert just takes the current bit value and inverts it. So if we have a 1, the result will be 0. If we will have a 0, the result will be 1. This is how invert works. And why do we need these operations? Well, so let's say we have inside this port B register we have the following value. Yeah? And now we just want to clear bit 5 here, but the rest should stay the same. So our result should be 0, 0, 0, 0, 1, 0, 1, 1. And we want to get this value without changing the other values here. So what we could do to achieve this is we could AND this value up here with all 1s, except for this bit here we want to clear. So this operation here will give us this result. But how do we get this value here? Well, it's quite easy. We have to shift a 1 by 5 here and then invert the value. So 1 shifted by 5 is equal to 0, 0, 1, 0, 0, 0, 0, 0. And if we invert it, we will get 1, 1, 0, 1, 1, 1, 1, 1. So this is exactly the value we have in here. So this is how to clear 1 bit in a register. But how do we set 1 bit in a register? Well, oh, I've deleted a little bit too much. I just want to delete this here. Okay, so let's say we want to set bit 4 to 1. So the result should be 0, 0, 1, 1, 1, 0, 1, 1. Okay, what we could do here is we have to OR this value with 0, 0, 0, 1, 0, 0, 0, 0. So here, only the bit we want to set has to be set here. And this value is just 1 shifted by 4. Okay, so this is how we can set one single bit. And then there is one last operation I want to show you today. Let's say we want to toggle the value of bit, let's say we want to toggle the value of bit 5. So if it's a 1, we want to have a 0 in it, and if it's a 0, we want to have a 1 in it. Well, here we could use the XOR operation. How does XOR work? So let's say we have 2 bits, and here we have a result. And let's make a little truth table here. So if both pins have the same value, the result will be 0, but if the 2 bits have different values, the result will be 1. This is how XOR works. So to get this, we would have to XOR, this is the symbol for XOR, 0, 0, 1, 0, 0, 0, 0, 0 to it, and the result would be we would have toggled bit 5 here, and the rest would just stay the same. And if we would toggle it again, so now the result will be a 1 again. And this value is again 1 left shifted by 5. Okay, cool. So these are the basic bitewise operation you need to use for setting and resetting bits in a register of our AVR 8-bit microcontroller. Okay, so I guess that's it for today. I hope you've enjoyed the video and learned something, and I hope I will see you in tomorrow's video. Bye!